My name is Goudreau. I welcome you to my session on how to optimize productivity with code generator. I'm wondering, there's a lot of people in the room right now, so how many of you have ever wrote a code generator? Well, there's quite a lot. Actually, in the United States, there were like 1 or 2 ends, so maybe there's more people interested into increasing productivity. So there's a lot of usage with code generators, and personally, I've been using it in a lot of projects, whether it's for clients or for our own products. But before that, okay, let's go to the next slide, please. Computer. There's always something wrong. Oh, there's only 1 slide. So I won't have the GWT.create logo for Euro then. So a little bit about myself, just quickly. I don't think you're here for that, but I founded a business called ArcBees. It's my 3rd one. We specialize into building developer tool for GWT, essentially, and Google App Engine. I've done quite a lot of talk on the MVP pattern as well, and code generator. And, well, I'm an adventurer. What I mean is that I like to do rock climbing. The business is based in Quebec City. We have 3 products right now: GWT, GA Studio, and Jukito. And I won't go into the detail of each product, but GWT has been the first product that we've been working on that used a lot of code generator, and this will serve as example into this presentation as well. While you're building a framework over a pattern like MVP, which is reusable, which is almost always the same things, you want to generate as lot as possible for your users, for the users of your platform, so that they can actually be more efficient in what they're doing. But this is one side of the story. You want to build code generator to be more efficient, to be more productive for the user that is using your framework. But you also want your code generator to be clean, to be maintainable, and to be able to actually modify them. The usage shows that when you build a code generator, you usually modify them maybe a year later. So once you're building it, you're testing it so extensively that you end up not having to really modify them over time. But once that happens, when you want to really make your project evolve to the next step, it's often really hard to get into those little pieces that you developed 1 year ago, so that you're able to maintain and make more feature for your framework. So this was a workshop in the United States. Now it's a session. So I have to change a little bit what I've been doing. There was a lot more example the first time, so I will quickly go over some example and let you some time at the end to ask questions as well. So I will show you a simple example without code generator. It's simply a cell table, which is really a case that is often used by most of GWT developers. And the column definitions of a cell tables is a really good candidate to be generated. Actually, the guys at GXT do it as well. They use an interface to generate the table. And so they make a good candidate to show you a little bit how to optimize and how to use code generator to it. So after showing you the simple example, I'll go to writing up the first GWT generator. Maybe not cleaning up I will probably go and step over the cleaning up the code. The main the main thing to remember while cleaning up the code is to actually be able to extract a repeatable pattern over what you're actually doing. So it is really important to extract something that you have, excuse me, that you have to repeat over and over. So in those scenarios, when you want to have good candidate for code generator, you actually have to throw away a little bit of the try principle and actually repeat yourself over and over to have something that is really a common pattern that is repeatable by your developers. And this is what will make a good candidate for code generation. I'll talk a little bit also of the main classes that are used into good code generator. And well, once you have questions at the end of the session, I'll answer them. So, once upon a time, there's always a case where you end up having a business problem that is repeatable over and over. Here in this example, it will be a simple cell table over a car scenario. So you have to build brand ID and the car name over your cell table. And with that, we will be building the first code generator. So one of the main things that I want to remember every time that I write something, whether it's a code generator or just code itself, is that simplicity is the ultimate sophistication. So what I mean is that to be able to build code that is maintainable and easy to extend, you need to make it as simple as possible. And when I first wrote my first code generator, it was a class that has like 1,000 lines of code, and it was a single class that was far from being simple at all. So over time, we managed to change to improve the way we were writing code generator through templating, to other kind of tools that would help us write a lot less of code. We were even using dependency injections to be able to extract all the responsibility of all the class in single classes that have a single responsibility. So it makes a lot more classes, but they are all a lot more simpler and easy to follow for when we want to extend them and add behaviors to them. So this is the simple cell table that I will be building. 4 columns, an action, rating, car, ID. Well, nothing really difficult there. Everyone here could write it. Yeah. When you're defining a cell table with a GWT, there's always 4 lines that you're repeating yourself to be able to pass the name of the column as well as pass what will be shown in that column. And then you have the type of columns. You also can add sorting and things like that into your cell table. And each time that you're writing one column, you have to repeat over and over the same process. So I'll show you a little bit what I mean. So for each column of this table, you have your ID columns, new column, it's a number, get ID. You have your column rating, and the column name. So 3 columns in total, you have your action as well. And that's make quite a lot of code to initialize 4 columns. So maybe something can be done. And the first thing that I did afterward is to extract all the column definition into its own class, so that it looks a little bit more like this. So I have a column initializer that initializes each and single one of my columns like this, so that in my view itself, I don't have to bother about this logic. When it's extracted, we can already see a common pattern where when you have one function by column that is being initialized, and this is what we need to generate, all the column definition. So we need an interface that will replace this class, and that will be generated at compile time that will replace all this code that I just wrote myself. So if I go back to the presentation now. Well, that's a level of code to write. This is a simple table. Imagine a bigger, just picture yourself writing a bigger table. When you're building business applications, you have often a lot more columns and a lot more behavior that you have to add to your table. And then if we take a look at the GXT cell tables, they have a lot more information and action that you can actually do with the table itself. You can right-click on the header, do an action on the column itself. You can sort it. You can remove some column, add some of those. So when you think about it, it adds a lot of logic that you have to add to each of the column. And this is what we want to avoid. What we want to give the possibility of to our users to be able to write something that is as simple as possible for them, so that they can actually build a table a lot more faster. And in your business application, it will give them a lot more power to do that. So going back to coding session, I've already shown you the cleanup itself that I did. So extracting the responsibility of creating the column into its own class is one of the first steps. If you're looking at the MVP pattern instead of this, for example, you will be creating over and over the same lifecycle methods that will be taken care probably by your by a superclass that will do that for you. And then if you're doing, if we take, for example, GWT and the MVP pattern, what we had to do to be able to do easily code splitting is to add proxies for each and single presenter that you're writing. Those proxies are always the same code. So instead of writing it ourselves, we decided to code generate it. So the proxies that you're using in GWT to generate, to be able to enable easily code splitting into the framework are actually code generated by the framework. But it's not the only thing that is code generated. But that's a good candidate once you really extract all the behavior into their own shell. Let's close this one. So what is important in the code? The class that are important to know in the code generators, for those of you that doesn't really, that never wrote a code generator, there's the generator class itself. The generator class would be extended by your generator that you're going to write. So in this generator, you get 3 arguments: the tree logger, the generator context, and a type name. The generator context has already, has a type oracle inside it that you can use to explore the types that are under your application. And this type oracle is already pruned from all the class that is not reachable by the JavaScript code. So for example, if you think about, because you could use any other type of code generator, basically. You could writing Java from GWT generator is not the only way to generate Java code. So the advantage of the GWT generators that is provided by the GWT framework toolkit is that you actually get a pre-pruned tree of all the types that you have. So all the types that are not accessible won't be available into the type oracle. So you won't be trying to reach the world if you have a lot of libraries into your application. You also get a lot of utility class that lets you have information on each and single class, like the G class type that is returned by the type oracle. Those do a lot of reflections inside of it. So you could do the reflection yourself, but you already have access to a lot of utility that gives you the class name information and things like that. Another thing that is important is the print writer itself, which it needed to print your class. You have to initialize each and single classes that you're doing. that you're writing with the class source file composer factory. The source writer will help you write the code inside of that class. And then if you have properties into your GWT.xml, you can reach it with the property oracle. So the class source file composer factory and the source writer lets you write code with strings, basically. So this is really awkward when you're trying to build something that is using object-oriented. So, and this is really you can make errors really easily by doing that. So I try to avoid that as much as possible. The first few code generators that I did, I was writing the code basically into strings that I was adding one line at a time. At some point, I just tried to make a lot more functions out of that, extracting some of the logic and then using statics variables on top of my class. That cleaned kind of most of of what I already did, but that wasn't enough. So I ended up using code template, a template engine. I don't know if any one of you have ever used Velocity. So this is the templating engine that I use, mostly because there's 0 dependencies into it, so that it doesn't collate with your dependency tree. It's really easy to use once you get to know it, and it cleans a lot of the work that you have to do. So now, what would look like my code generator? But beforehand, what would look like the interface that is needed to write my code generator? So as we remember, we had this class here that was initializing 3 columns. And then I rewrote that class to do an interface called that looks like a little bit more like this one. I made it clear, and I added a lot of information into annotation so that I don't have to use a lot of reflection to get all those information. But you could generate something you could create an interface that is a little bit simpler than this one, but you will have a lot more work to do by reflection to get all the types that you need. So it was just a matter of how far you want to go. In this case, I use it the simplest case as possible so that I have the simplest code generator. So what do I need? So I have a DTO. I need the class of that DTO to know what will be the object used by my code generator. I need a column definitions as well, the column definition as well. So for each column, what I did is that I took exactly the same getter name of what is inside the rating DTO class so that I can reach them easily. You could do the same thing by doing reflection on the object and getting all the getters that is accessible, and even adding an annotation on the DTO itself. So it's up to you the strategy that you want to use. It's up to how you want the user to interact with the framework. But here, there's a constraint with this methodology where the getter name that I'm using into my interface must be exactly the same name as it is into my DTO class or model class. On top of that, I had the cell type, which will be what will be returned, what would be used as a cell into my column, the return type that will be returned by the getter itself, so that it's efficiently shown into the column, and the header name. In there, you could add as well static strings instead of those. So going back to my presentation now. So, what do I use now after writing a lot of code generator? I use a lot of classes that that I call class definitions that include all the information needed by my template to generate the code that it's needed. I also use dependency injection, a template engine called Velocity, and there's even more than that, because if you took any one of you have ever heard of ArcBees, the ARI project? Well, they also it used really a lot of code generation into that project, and they made a tool to do the reflection themselves that is a lot more powerful even than template, and it's strongly typed as well. So you can go even further if you want to maintain your code more easily. So if I took a look at the template itself, those are the macro for generating the functions that we saw a little bit earlier. So each one of those. And then I have the template to call each method. So if I go up a little, that means that I have a little for loops to create all those methods. And then this is a macro. Since it's an interface that I'm being generated and I use the class, I need to recreate all the getter that I added into my interface. So it just creates an empty method for it. And then I have a template that creates a class and call the macros that I just defined it. So that's what it's behind the template itself. A lot more. I try to keep always a copy of. What I want to do is that I want the user to be able to either choose between code generation and not code generation. So if he wants to build a pattern manually, he should be able to do it. So that it gives you the opportunity. It gives me the opportunity to write. When I work on on GWT, for example, I always have both trees so that I test. If I do major changes to the architecture, I can actually test those changes into the real classes before going to do the change into the templates and the code generator itself. So I always have an application that is working through normal means, and I have this tree, and I have the code generation option that I can use. So in a major project that we did for one of our clients, they have 300 developers scattered around the world, and they are working with 20 of the biggest banks of the world as well. So what for each and single entity that they are working with, they have a single team of maybe 10 people that are working for each one of them. And we have a core team that is working on a framework that all of those entities are using. And we built a framework for them on top of GWT so that they are able to actually create their own application and use any kind of module that we built as the core team. So there's like 8 modules that has been built by the core, and each banks only implements the one that they buy, and the team that is working for that bank build often a custom module for that bank. Where I want to go with that is that we also build a sample for the developers so that they can all the widgets that they can use, all the widgets that we built for them. And all the tests, the integration tests that we're writing to actually confirm that the code generator is working are in there. And we kept in there both trees where we can actually write the code by hand or by code generator. And every single test, whether it's cucumbers tests or unit tests, are there on top of what you have to actually write for your own module themselves. But for the framework, they are into that sample project. And that gives the developer the ability to not only use the code generator tree and possibilities, but that gives him the possibility to understand what's going on behind the scene if he ever wanted to contribute to it afterward. So the generator itself look like this using dependency injection. Well, there's not. I don't know if you ever. For those of you that ever wrote the code generator, you can understand that there's quite a few lines of code there. Almost none, actually. I will show you another one. One of the first that we wrote, actually, that it's still in GWT. By the way, all the code that is that I'm showing you is available as an open source project in my sample project for the GWT framework. So you can actually have access to that code, run it, and use it. I don't want the next tip. So one of the first code generator that we wrote for GWT is the one for the proxies that I was talking a little bit earlier. The proxy is a great tool, a great lightweight tool to start the initialization of each presenter and making sure that your presenter doesn't end up into the leftover fragment of the code splitting feature of GWT. And this has been greatly enhanced through the year, but it's still, a lot of line of string and functions, and there's other classes behind that are being called to write the source code of those classes. So this against this. Okay. So there is a lot more behind it. It's not only that. Okay. I was kind of, showing something really big, but it's not that beautiful. There's I've built an abstract class just to, because I'm doing this generator. This abstract class actually is used among other code generator. In this example, I'm using only one code generator, so I shouldn't have needed that class, but since I extracted it from another project, I've reused it. So basically, it called the merge process of velocity, so that it gives all the information to velocity to be able to build the class, and it calls it the definition itself. I've built the velocity column initializer, which this one is included into the generator itself. So the juice actually, when it creates the module in the generator context, will simply initialize the velocity generator and then return and generate the code. You could have more than one in that. Actually, I have projects where I have 10 in rows. That is, from one single line of GWT.create, I'm creating several classes at a time. You don't have to create only one class per interface that you're creating. You could create basically your whole application through it. And from the client that I just told you about before, what we're doing in Code Generator is that in GWT, you have a hierarchical way of showing an application from top to bottom, from what is actually the leaf to the end of the application. And the only thing that the developer has to write is actually the leaf. Everything else behind, until the top, is being automatically code generated I will show you a little bit of that later on. So going a little bit further, Velocity take the templates, create the code generator, create the code that you want to use. I don't have example here of the classes that I'm using, but I will. There's 2 utility class that I'm using through that. So the generator util just a way to return my logger, the creation of the print writer, the types that I need, so that I don't have to redo that everywhere else. And there's the definitions, all the reflection that I need to get actually get all the information for my template. So all those information, all those type is used into the template itself. And that's where it becomes interesting. Using you could do that in Eclipse as well, or in IntelliJ. You had those little type definition on top of your class, of your VM, and then you have access to every single type that is inside that class. So you actually have code completion into those things. So it's really easy to manage and make sure that you don't mess up with the function name and things like that. And if we go back to the proxy generator, a lot more different. Honestly, I wouldn't do any more code generating without using dependency injection. And that's what I did for the new injector, the new code into GWT. We added a new functionality that create. Is there a lot of you that use Gin in Gwt? And quite a lot. Or any other kind of dependency injection framework, maybe a homemade. Yeah. So in Gin, you have a concept of injectors. And if you're using a platform like GWT, what happened is that for our user, there was a single task that was really cumbersome that you had to do every time, which is to include a getter into the injector for each and single presenter that you had, because the proxy code generator needed those getter to be able to generate the proxies. And since we didn't have those information yet at the time of compilation, we needed the injector to return them. So what I did is that instead, I used the type oracle. This is kind of an heavy usage of it, is that I use a type oracle to return, and I ask it to return all the classes that is available to me that extend the proxy, the proxy interface, the proxy annotation. So I get a dictionary of all the presenters that I need, and then instead of using the generator into my application, I just throw it away. I don't need, not the generator, the injector, sorry. So I just throw it away from what I really needed and started to generate those injector. And that gave me a lot more power into my application. That gave me the possibility to generate not only injector, but also Gin modules from it. So that's where I want to go with, so that little ability gave me the possibility to create not only the injector, but also a form factor. I had to create a form factor generator as well. What it is that you can actually do permutation pair using dependency injection per type of sorry, desktop. Well, you have desktop, mobile. Yeah, target device per type of device, exactly. So you can actually build. There's a tree form factor that is included already into GWT, as in it's mobile, tablets, and desktop. So basically, it creates one injector for each of those platforms. And when Gwt compiles the code, it creates a permutation for each one of them. So you only have the code needed for either mobile, desktop, or tablets. So that gave me the ability. Generating the injector gave me the ability to do that, and gave me also another ability that I find really interesting, and that we introduced it into the Zafin project. Not this one. And it's the ability to build a modular application that is built from a single Gwt.xml file. So I don't have source in this code, as you can see. I only have resources. And in that, I only include the module that I want, and the application itself is built from those modules, because the gen module that I will be included into my injector are actually properties inside the Gwt.xml file. So for a business like Zafin, it made a lot of sense, because they have all those scattered teams around that needed individuality, that needed to be able to build a module without messing with others' code. They needed also the ability to build a single application that didn't have always the same modules, because a client would want an application that is different from another one, because they wouldn't buy the same module for each times. And this, with a single Gwt.xml, gave us the ability to do that. And by creating a framework at the base of that, the user of that framework would be each team that will work on those individual bank client. And that was really awesome, because, well, this application, I'm not showing you the whole application, this is only the sample, but it has around 500,000 lines of code total for each module. If you count every module, the framework, and the specific implementation for, there's 4 banks now that is using it out of the 20 clients. 500,000 lines of code. How long do you think it will take to compile using Gwt? Half an hour? Okay. Someone else have an idea? I will show you how long it takes only for the core, because they are modular. I don't have to recompile everything every time. At least I have a good connection, so I'm on the cable. I'm not running the integration test, by the way. Okay, how long? 25 seconds. So this is one of the fastest one, okay? But the slowest one takes around 2 minutes, the biggest. If I go, that doesn't include Gwt compilation in there, that's only the library. If I go into the sample, it will include the Gwt compilation. This one is a little bit slower. So since the application is used, you only have to compile your application modularly, and that you have libraries that are used by others. The core itself is really fast to compile itself. You saw it, 25 seconds. If you compile each individual module, it will take around that time as well. It's when you compile and applicate the module, the combined application, that it's a lot slower. But we're still less than 30 minutes. The sample is a lot faster to run than a complete application, but the complete application would take around twice the time. So, less than 2 minutes. Now, let's see what it's looked like. Just to talk to you a little bit about more about the architecture. So in this application, the only thing that the user of a module I have to define is this over there. Everything else has a registration process to bind the module to the main menu, to bind the submodule to the tabs system, which are all, by the way, bookmarkable. Everything works through the history. Sub-tabs as well. So you can actually go back into the history. Yeah. And people only define what's in there. This is a special system that is taken care of through code generator as well. The user defines what is on the left side, the user defines what's on the right side, and everything gets bound together. Okay, that's a dynamic. Create 5 tabs. Do you want to take a look at what the code looks like in the generator a little bit? Okay. So you have, since it's a hierarchical way of showing things in GWT, you have the basic of the basic, the root of all classes, which is the application presenter. It's a single presenter and a view that is generated through code generation. And then you have another layer for the page, the first layer of tabs on top, which is the GUI page presenter and the GUI view, and the GUI page presenter and the GUI page view. And then you have the other layer, which is a second level of tabs, which is the view and the GUI view itself. So a lot of conditional logic. In a year, all those files didn't have changed. I have to change it for January though, so I have to add a new behavior to it. But that being said, now that it's looked like this and that I also have a tree of, I will do the modification into my sample where I actually doesn't use code generator. So I'll make sure that it's working first, and then I'll be able to modify my template so that it produces the same thing. And it becomes really easy. It's a matter of maybe a day or two of work to be able to do a big architectural change that I need to do, which is in the dynamic table, they want to add a new code generator so that the user doesn't have to. I will show. Do I have this here? Well, I can show you really fast. Well, there's 10 minutes left. Maybe you have questions instead. Yes, over there.
Questions about unit testing, or for instance, if you use Goudreau,
Yeah.
how do you pipeline code generation plus unit testing plus application assembly?
Okay. So in this case, it's really hard to unit test code generated class that doesn't exist. You have to compile your application if you want to do it. So you need to either go through GWT test case, or in my case, what I do is that I build the unit test on. That's why I always keep 2 trees of the code. So I have unit tests on all the code that is what I want to generate. So those are really fast unit tests. And I do integration tests using Cucumber for the whole application so that I'm sure that even if I do changes, it's still working. Unfortunately, it's really not easy to unit test those kind of class. Even the messages that you're receiving when you do a test are kind of weird. So from time to time, your IDE will tell you something. It won't be enough. You actually have to use Maven or any kind of other builder to have another message that is a little bit more, that gives a little bit more information. So I hope that answers your question. Any other questions? Yes.
Can we have subclassing for templating as we have it for Java? Can we have some general template in velocity and some concrete templates?
Can we have some? I don't understand, sorry. Do you want to show?
Several templates.
Yeah.
And some logic repeated in
Yeah.
templates. And I want to declare some basic template that has general steps.
Yeah.
And other templates call this general template.
Yeah.
Can you do this with velocity?
Yeah, you can do this with Velocity. You have a macro system. So if you have general logic that you can reuse through all the templates that you're writing, I think I've shown a little bit of an example of that earlier. There I don't have macros, but if I reopen the generator. Hey, where have you gone? Okay, I'll go there. So if I go back to the templates here, you see this file here is a macro file. So each of those macros here that you can define are used into this real template here. So this call the macro that I've defined init columns, init empty methods, call init columns. So those are the 3 macros that I defined into that file. So if you have things that you repeat over and over in all your templates, you can actually use macro to avoid having to rewrite this. Does that answer your question? Cool. Yes?
Another question. Could you explain how you make it so fast for the compilation, grid compilation?
It's just a matter of separating into smaller projects part of the applications. So, what?
Oh, it's a trick more. You already compiled the grid parts and they are being included as a JavaScript and referenced as a module, if I understand you correctly.
Yeah. In some cases, you can go further than that. That's just a matter of, the first step is to separate into different modules what you're doing. And then when it's done, you can go even further than that by parallelize the build themselves. And even having, if you go even further, having each of the permutation running in a single core of your. So most of those things on my computer it's not done, but most of those things we included that directly into our continuous integration servers. So when the continuous integration server actually builds our application, it's all done automatically, the parallelization of the build as well as the permutation. So this is only the first step, basically. Yes?
You said that you have two source trees, one with templates and
Yeah.
one with expanded templates. Can you somehow take this template code base and turn it into the other, or somehow check if they are synchronized, that there are no differences?
Mm-hmm. Well, you can use one or the other, actually. Yeah. I could get rid of the tree that I wrote myself instead of the tree, instead of the one that is code generated. I could get rid of it, actually, and use only the code generator. But for a matter of being able of using unit tests, fast modification to the framework, and being able to have a clear example that I can look upon, I keep both of them.
But can you actually verify that it's the same? You did some modification in one branch, and you want to be sure that you have exactly the same in the other.
Well, I never did, but yeah, you could. You could compare basically string the class that is generated with the class that you already have, the strings. The only problem is normally when you code generate something, you use the complete name the qualified full name of the class, and when you write something, well, I don't know for you, but I don't use the qualified names. No, so just comparing the string is not really enough. You have to so that's why I'm building. You could automate that if you obfuscate all the qualified name somehow and build something to compare efficiently those two parts. But that is why I build a complete integration test over the framework itself, so that for one module that is not code generated, I have exactly the same test then for that module that is code generated. So if both of those pass correctly, well, that should mean that both are the same. And well, this is done. Thank you. Then one last question, maybe? Yeah.
I have a question about the generation.
Yeah.
The repetitive pattern we have is build the form, fill the form, check the fields, and display errors. You know?
Okay.
Do you think it's easy to integrate the integration framework using this pattern?
Well, if you think about GWT, they already do something. When you do when you use the editor framework, they do bean validation through that through GSR 303, and they're actually doing code generation for that. So, saying that it's easy will be lying, but it's doable. Well, thank you, everyone, and if you have any more questions, you can just come talk to me afterward.